Good morning and welcome to this AutoCAD webinar. My name is Dr. AKM Saidu Zaman PNG and I am a professional engineer in Ontario, Canada. Before we begin the drafting process, I would like to emphasize the importance of AutoCAD proficiency for engineers. Technical drawings are the foundational language of our profession. They enable engineers, architects, surveyors, contractors, and regulators to communicate design intent precisely and efficiently. While CAD drafters often support the preparation of drawings, engineers must be able to create, interpret, and modify their own technical drawings. This ensures accuracy, clarity, and direct control over design decisions. AutoCAD, therefore, is not just a drafting tool. It is an essential engineering communication instrument. To begin, I will display the survey PDF on screen. We engineers are often challenged with developing an accurate site plan because clients frequently provide only outdated survey plans in PDF format. These documents are often difficult to read and cannot be directly converted into AutoCAD drawings. However, we can still extract the necessary information and use it to develop a workable site plan, which becomes the foundation of our design work. So let's find the drawing from here. Mm, okay, so let's zoom out a little bit so you can see the entire drawing. Okay. So this particular survey includes the bearings, distances, chord lengths, and chord bearings and radii needed to reconstruct the property boundary in AutoCAD. For straight line segments, distance and bearing angle are sufficient. For curved segments, additional information such as arc length, chord length, bearing reference, and radius is required. It is important to review and interpret this information carefully before entering any data into the drawing environment. Let me zoom in a little more to show you the information we extract from such site survey plan. You see the bearing reference here and 13.26 meters the distance. Similarly, here we have the bearing angle, and this segment is not about, should be exact. It is okay. So okay. So all right. So the length of this segment is 31.53 meters. So now if we look at the other segments, we can see that there's a curved line here. There's again a straight line and the curved line after, and all other line segments are straight. So I will now transition to AutoCAD, where all steps will be completed in real time, including unit configuration, textile adjustments, dimension, the style modifications, and the full reconstruction of the surveyed property line. Let's get out of here and let's start the AutoCAD. The first step is configuring the drawing units. Since the survey data is presented in meters, I will set the drawing units accordingly. Let's select meters here. Let's make the precision 3 decimals and let the angle degrees, minutes, and seconds, and let's leave the clockwise unchecked. Apply, rescale, OK. Before starting the boundary layout, it is good practice to establish consistent text formatting. I will modify the text style so that all annotations in the drawing use the Arial font. Okay, so let's find Arial from here. Arial, okay. And it should be up somewhere. Okay, so okay, got it. Next, I will update the dimension style to ensure that all dimension text also uses Arial. Maintaining consistent typographic standards improves readability and contributes to a professional presentation. Okay, let's modify this and text. Let's change the text to Arial. Okay, apply. Okay, close. We will now proceed to input the straight boundary segments from the survey. AutoCAD uses relative polar coordinates for this task, entered in the format at distance x less than bearing y, with the bearing expressed as, for example, north 29 degrees 53 minutes 45 seconds east. I will now enter the first line segment followed by the second segment using the same method. Entering the first segment, bearing is N29 degrees 53 minutes 45 seconds east, and distance 13.26 meter. So let's type line, and then let's as we discussed should be at 13.26 and then less than, oh no, then less than, okay, less than, we got N29 degrees, D4 degrees, 53 minutes, 45 seconds east. Enter. So now we got our first segment. Let's do the second segment now. We have the bearing north 59 degrees 49 minutes 55 seconds west, and the distance is 31.53 meters. So let's type line, and let's start a point here, and then we put the out. So we have 31.53, and then at what we have N59 D4 degrees 49 minutes 55 seconds west. Hit enter, enter again, and we got our second segment. Let's save this for now so that we don't forget, right? So let's save it somewhere. Desktop. Let's name it webinar drawing, right? Okay, so let's save it for now. Now we got the second segment. The next boundary element is a curve. The survey provides the chord bearing, chord length, and radius. AutoCAD cannot construct arcs directly from chord bearing data, so the correct procedure is draw the chord as a straight line using its bearing and length, convert the chord into an arc using the start end radius option. I will now draw the chord and apply the radius to generate the arc. Curve segment example, chord bearing north 62 degrees 59 minutes 45 seconds east, chord length 7.17 meter, radius 20.12 meters, and we had arc length 7.21 meter. To input this segment, let's type line. Okay, enter. Now we need to start somewhere, right? So from here, for example, and then we put at 7.17, right? 7.17 7.17 meters, okay. And then less than sign N62 D for degrees 59 minutes and 45 seconds. 45 seconds east. Okay, so hit enter, and we got the chord here. Okay, now that the chord is drawn, we convert it into an arc. So let's type arc. And then start and radius. I don't see the okay. Oh, okay. So let's do it in a different way. So let's choose from here. Okay, arc start center and arc start end angle, arc start end radius. So that's what we want, right? So let's do the start end and radius 20.12, right? Okay, is that the direction we had? Yeah, I think that's the direction we had. So let's double check if we had that kind of direction. Okay, so SPC desktop webinar, and it's okay, so it looks like we did the right way. Okay, so that's correct. So let's move all this to this point now. Okay, so we got the, let's hide this for now because we got the isolate and hide object. Okay, so now our next segment is a straight line. So you see we have drawn a curved line with the data we extracted from the survey plan. So any additional curved segments will be created using the same procedure. Now our fourth segment, the straight line, has a bearing of n, meaning north 73 degrees, 16 minutes and 0 seconds east, and the distance 5.19 meter. So let's draw a line and at 5.19, and then our bearing is 73 degrees, 73 degrees, 16 minutes and 00 seconds, right? East. I'll put east. No. So we did something wrong. Okay. So let's do it again. Let's do it again. So let's start from here and at 5.19, then less than N73. N73D, 16 minute, 00 seconds east. Right? So this one is our next curve, right? Next segment. Okay, so let's check the properties. What we got? Let's see, length 5.19. Oh, that's okay for now. So let's now do the second curve segment now. So we have chord bearing in 28 degrees, 26 minutes, 35 seconds east. So we need to create a chord 8.96 meter with a radius of 6.35 meters. Draw the chord now. So let's draw the chord, deselect and type line. So from here, for example, at what 8.96 meters, and then N28D N28D, 26 minutes and 35 seconds. East again, east, right? East. Okay, so this is the next segment we got. Now this is going to be a curved line, right? So we need to convert this into an arc from here. So let's choose our start and end, and the radius 6.35, right? And then hit enter. So we got our second curve. So this is one curve, this is a straight line, and this one is another curve. So we are getting there. So let's quickly save. Now let's see what it is. Now we need to do the next straight segments. We need to draw 13.87 meters, and the bearing is north 16 degree, 44 minutes and 0 seconds west. Okay, so let's do that. So let's type line. Let's put it here and at what 13.87, right? 13.87. Okay, then N16D, 44 minutes, and 0 seconds west. Okay, so this one needs to be here, right? So this one is here. Now the next point is, our next segment should be somewhere here, and at 30.5 meters, right? Then what? N73, D for degrees, 16 minutes and 0.5 seconds east. Okay, and I hit enter. So this one is our next segment, right? So let's put it here. Let's put the end here. Now we have the last segment remaining. So if we just connect these two ends, we get our last segment. Now, if we select all and join, then we get our property, right? So with all segments entered, the final step is to close the boundary to complete the property polygon. So that's what I did. This concludes the reconstruction of the side of the surveyed property boundary in AutoCAD, completed using bearings, distances, chord bearings, chord lengths, and radii. In this session, we reviewed the survey document, configured drawing units, standardized annotation fonts, and constructed all straight and curved boundary elements in real time. Please feel free to ask any questions. Just leave them in the comment box and I will be happy to respond. Thank you for your attention and participation in this webinar.